Hey everyone, this is Thomas with Polyga, and today I'm going to give you a little tutorial on how to do 3D scan data inspection. One of the most common questions we get here is the scan data that you gather is nice and good, but what you really want to be able to do is do a inspection versus your CAD file, or do a inspection versus a golden part. One of the big misconceptions that people have is in order to do that, you need a lot of skilled engineers or expensive software or complicated fixturing. And all of that couldn't be further away from the truth. So what I did today was try to set up a little case study on doing scan data inspection and comparison versus a golden part, using simply one of our compact scanners, a rotary table, and just our built-in FlexScan 3D software. The part I've chosen to do are these little paper stamps that I've stolen from my wife. They're plastic injection molded parts. This one will serve as our control example, and this one will represent one of our bad parts. They look the same, but what I did was also, being the bad husband I am, I took a screwdriver and really gave a big scratch to one of these paper hole punchers. Hopefully my wife doesn't actually watch this video, so she didn't find out that I'm the one who actually damaged it like that. But the things we have to sacrifice to make interesting looking videos. So first things first, what we're going to do is take our golden part, we're going to scan it onto the rotary table, and we're going to generate our CAD or mesh file that we're going to do our comparison off of. So here you can see a picture of the two parts. You can see very clearly the one on the left has a big scratch. And you can also see here, I've simply just placed the part onto the rotary table. So once it's on the rotary table, all I have to do is to pretty much just press the scan button. I did a quick test scan here just to make sure all the settings that I had set up were good. And because it's my kind of golden part, I set the number of scans to 8. And the reason why I kind of set the scans to 8 is, just at least for this golden part, I want to take a little bit more scans than I need, just so I have the most data that I want. As you can kind of see, I did a quick overlay of the scanning process along with it running the software. You normally don't see obviously the video of this happening at the same time. But you can see on the left-hand side, we're scanning the part. It's going super easily. It's just running on the rotary table. And all I really had to do is just hit the scan button. What we're going to do is we're going to do a full 8 scans out of this part. And once all these 8 scans are done, it pops right into our view. We're automatically going to align the scans all together so we fuse into a single model. It's pretty typical. It's what happens all the time. We're combining all the scans into a single scan. This part takes usually another minute or so, but it should be done relatively soon. And once all these scans are combined, we're going to end up with one single mesh that we can then use for analysis and inspection. So now that we've got our golden part scanned, we're going to take our golden part, and now we're going to scan the bad part. And that's what I've put on the rotary table now. I've got my second part, I've thrown that onto the rotary table, and I've now started scanning that. Because it's a comparison, I didn't do quite as many rotations. When I took the master part, I did 8. For the comparison, I just did 4. Obviously, you can choose whether you want to do more scans or less scans, depending on the type of object you have and the type of coverage you want. For the basis, at least this demo, I just did a quick 4 since I didn't want it to take too long. You can see once we get the part, this whole thing is going to combine and then do a automated comparison against our master model. One interesting thing you've noticed, it just flashed on the screen briefly, but you might not have noticed it. But because I didn't fixture the part, actually I picked up the part and placed down a new part. The new part was in a slightly different position, but that's okay because the software will automatically do a realignment. And you can see, because this is a injection molded part, you can see where it's under. You can very clearly see where it's within 0.1 millimeters and where it's out 0.1 millimeters. And you can also see clearly where we added a big gash onto the part as well. So I'm sure you've seen so far how very easy it is to do a basic comparison versus an existing mesh. I'd like to show you how to do a comparison in CAD as well, but maybe I'll save that for a follow-up video. But for now, what I'll do is, you've seen what happens when I've scanned a bad part. You've seen how things look in and out of spec, and you can get a very quick preview of it inside of the software. Now I'm actually scanning the golden part that we had again, so that you can see the results of what happens when we scan a good part. And with once you scan a good part, the process is identical. I remove the bad part, I threw the good part back on, and I hit the scan button. And the process is identical. And you can do all this analysis straight in the deviation window. So this whole process can be fairly nicely automated, meaning you don't save in the scan data, you just press the button in the deviation window, it'll gather data, it'll show you the output, and you don't have to worry about anything else after that. So right now you can see the data. When I placed it back on, didn't quite align up with the old one. So we run some basic alignment, and lo and behold, you can see the results is very nice. It's very green. In fact, our average is 0.01 millimeter difference. So this golden part versus essentially good part versus itself is looking really good. So I set it to 0.1 millimeter in terms of our tolerance. Now I'm going to reduce it a little bit more to 0.05 millimeters, and even at 0.05 millimeters, the entire object is pretty much completely green. It looks pretty good. So there you have it. I hope you've enjoyed my little tutorial on how to do automated inspection using 3D scan data.